Good morning or good afternoon. A happy Wednesday. This is September 18th, Wednesday, 2019. And hopefully you've finished about 15 to 20 minutes of Khan Academy and you leveled up and you did all that good stuff. And now we're on to our lesson for the day, Unit 1, Lesson 10, Angles of a Triangle. So now we're still working with intersecting lines, and now we're forming a triangle out of them. So in your textbook, you should have it open to Chapter 5, Lesson 3. That starts on page 389 to 394 through the independent practice. And our objective today, you're going to apply what we call the angle sum of a triangle. A triangle inside forms three angles, and those three angles always add up to 180 degrees. So we're going to look at and hopefully apply here the missing angles on the interior of a triangle. And then we're going to look at an angle that's formed if you continue one of those sides of the triangle out beyond the triangle, that we have a property of that an exterior angle is formed, and it's equal to the sum of two remote interior angles. Okay, so let's focus here. We are still now moving on to our final essential question that we haven't addressed yet. If we remember back, essential question 1 dealt with congruent figures and our three transformations. Essential question 2 was a dilation, forming a similar figure, and we talked a lot about similarity and proportions. In yesterday's lesson, we talked about angle relationships when we had two parallel lines cut by a transversal. And now we are looking at how are the angle relationships useful when we are inside of a triangle. So let's put a question mark here because these are essential questions, and move on to your book, page 389. And a quick scan of the lesson is going to reveal that if we look here, we have some vocabulary, triangle, interior and exterior angles. Now we're going to be interior of a triangle. And we have exterior of a triangle, and we're going to be talking about remote interior angles. We need to identify those. So we just do a quick preview here. We have angle sum of a triangle on the interior, and then exterior angle of a triangle. So that's what we're going to be learning here. The interior angles of a triangle and the exterior angle of a triangle. And that's page 390. And that's page 391. Okay. Now we're going to also introduce for the first time this year a little bit of algebra that's going to lead us into Unit 2, where we are going to be solving very simple algebra expressions for one variable. So it's a great opportunity for us to get into this beginnings of Unit 2. Let's take a look at this real world link real quick. We have a very interesting situation happening here. We have lines M and N are parallel. They're already identified with their parallel marks, which is super. We have a red arrowhead and a red arrowhead, meaning that these two lines are going through parallel. And we have a transversals. We have a transversal 1 and a transversal 2. They're also named, this one's named line R. This one's named line P. And let's look at angle 1 and 2. Here's the transversal line. Let's identify the interior of the parallels. And this is exterior. And this is exterior. So we have the transversal line. We have an angle 1 and 2. They're on opposite or alternate sides of this transversal. So what's true about them? They are alternate interior angles. I should have written the full word, alternate And we know that alternate interior angles, when we're dealing with parallel lines, are congruent. And now we can look, so 1 and 2 here are alternate interior angles. They also tell us, well, what's true about 3 and 4 here? We have angle 3 and 4. This is a different transversal line. And so 3 and 4 are on alternate sides. They're still crossing this parallel lines, but so 3 and 4 are alternate interior angles. We don't know what angle these transversals are crossing by. You can't necessarily say that they're the same yet. We have to do other things. Interior angles are congruent. Okay, and then we look here and they ask us 1, 5, and 3. Well, let's put our finger down and look at 1, 5, and 3 and look at this form. What we can see is if I hold that down, a straight line. So if I look at this, a straight line, the angle formed on the straight line is a semicircle. And we know that those are going to be angle 1, the measure, plus the measure of angle 5, plus the measure of angle 3. They add up to 180 degrees. Oh, and there we go. We've written an expression that says that. Use the information about exercise 1, 2, and 3 to draw a conclusion about the sum of the measures of the angles of triangle ABC. Well, if we know that 1, 2, and 1, 5, and 3, can't we substitute in 2 and 4? We're going to substitute in 2 for 1. So instead of measure angle 1, we could say measure angle 2. We'll leave 5 here. Measure angle 5. And in place of 3, can I put 4? Because we already talked about them being congruent. So we can switch 3 and 4. So let's put the measure of angle 4 there. So we just substituted, and we know now that they're 180 degree by substitution. We substituted 2 for 1 and 4 for 3. And look at that. It adds up to 180. We just proved that the interior of a triangle sums to 180 degrees. That's a very powerful thing that we just discovered. Good job. Give yourselves a pat on the back. You really deserve it. Turn the page, please. And we have our definition now. That any angle, x, y, and z, are going to add up. These are designated interior, x, y, and z. Let's put it, they've done a poor job here, of course. They should identify that these is a scaling triangle. This is unique angles. Put 1, 2, and 3 marks. And even better than what they're adding here, there's another error by the book. The measure of angle x plus the measure of angle y plus the measure of angle z adds up to 180 degrees. So let's look at a triangle is formed by 3 line segments. Big vocabulary here. Let's highlight some of this great vocabulary. Segments. Why is it a segment? If you look, there's no arrowhead here or here. It's a terminating section of line, so that we call that a line segment. A segment means a part of a line that intersects only at their end points. Okay, when they intersect at the end points, those become something we call a vertex. The point where the segment intersect is called the vertex. Highlight that. This is big, great vocabulary. The angle formed by the segments that lies inside the triangle is an interior angle. Why is it interior? Because it's inside the triangle. Okay. I just happened to come with my pen, hit this tutor. Every time you see a tutor or a watch, those are tutors are going to be an example that's very similar to this. And if it says watch, you can go home, find this section of the book, and you can watch the exact problem. And most of these tutors are available in English and in Spanish. So example 1, find the value of x here. So they've got this triangle. Notice what they have here. There's a mark here. It's very hard to see. I'll make it a little darker, and it forms a little square right there. Whenever you see this mark, I want you to write 90 degrees. So now we have a missing angle. We have a triangle formed. Inside we have 55, 90, and x. Okay, well we know that 55 plus 90 plus x is going to add up to 180 because there's 3 angles inside, and we just proved and had the key concept tell us that angles inside of a triangle add up to 180. So we need to be able to combine like terms. 55 plus 90, oh, that's a tough one. Well, I know 100 plus 55 is 155. And then that's 10 less than 100. So let's go to, it's 145. Now I have x over here. I have 145 on the left. In order to undo that, I have to do an inverse operation. The inverse of, to undo 145, to get it to 0, I have to subtract 145. If I've done it over here, I have to go all the way onto the other side of the equal sign. I'm going to make a little line here because I want to subtract on the right side of that line, minus 145. 145 minus 145 is 0, and I'm left with x equals, I need to borrow, that's a 7, 10, 10 minus 5 is 5, 7 minus 4 is 3, and it's in degrees, so put a little mark here that looks like that. That is called the degree mark. Okay, we have a triangle XYZ, and one of the angles is 72 degrees. Another one is 74. They have not done a good job of visualizing this, so let's draw this triangle right over here. I'm going to draw a line here, and I'm going to mark off on this line 72 degrees. And 74 degrees. Approximately. I just want to get kind of an accurate triangle here. If I connect those, I'll form a triangle. Okay, and this triangle had 74 degrees here. Okay, and that was angle Y, so we'll call that triangle Y. 72 degrees here, and that is X. Notice that the triangle is drawn accurately. This is an acute angle, and that's an acute angle. An acute angle means it's less than 90 degrees, and then it forms this third angle up here at Z, and we want to find the measure of angles here. Let's call it X. Okay, well, we know that we can add them up. 72 degrees plus 74 degrees plus X is going to equal 180 degrees. This is 100. When I add this together, I get 146 degrees plus X equals 180. You can then solve it algebraically, or you can use mental math. I'm going to do mental math first. Let's say it was 30. That'd be 176. It's not quite there. I'm going to say, okay, then 30 is not enough. That gets me one. I need 34. So X is going to equal 34 degrees. To do it algebraically, I'm going to subtract 146 from both sides. That's 0. I'm left with borrowing here from the 8. I get 7 tens here. 10. 10 minus 6 is 4. 7 minus 3 is 34 degrees. There's my answer for A. Okay, let's move on. Example 2. There's these little areas over here. Talks about segments. the AB, and then they put a bar on top, so it's teaching you a little review here that when you want to read segment AB, it's because the bar above AB has no arrows. If it had a single arrow, it'd be a ray. If it had two arrows on both sides, it'd be a line. So then you want to always name the sides of a triangle with the segments on top and two letters. Okay. So naming a triangle, this is AB, but it's written like that if you're going to describe it to somebody else. All right, number 2. The measure of the angles of triangle ABC are in the ratio of 1 to 4 to 5. Okay, well that's what they're talking about is the angles here. If I called one of the angles x, then this would be 4x and 5x. So we're dealing with a very, very small angle. I'm not going to, I'll draw some theoretical small angle here. Because that first angle is very, very small, I'm sorry. We could call that 1x. We could call the next largest one, which would be here, 4x. We call this one 5x. 3 inside angles are in this ratio, so we're just going to put an x after them. What's the measures of the angles? Well, if I know that if I add them all up, they're going to add up 1x plus 4x plus 5x. If I add them together, they're going to all add up to 180, because inside of a triangle, 3 angles always add up to 180 degrees. How many x's do I have total? I have 1 plus 4 plus 5. If I add the coefficients, those are called coefficients, the number in front of x, the variable. 1 plus 4 plus 5 is 10 x's equals 180. Algebraically, I would divide by 10. Using mental math, I know that 10 times what equals 180, and x is going to equal 18. If I do it algebraically, the inverse of multiplying by 10 is to divide by 10. And I draw a line for a wall. Because I did it to the left-hand side, I have to also do it to the right-hand side. So I know what x is. The smallest angle is 18 degrees. So then I need to know, okay, well, this is 18 degrees. 5 times x is easier to do than 4 times x, so that's 50. 5 times 8 is 40, so this is 90 degrees. 5 times 18 is 90 degrees. And so I need to subtract 18 from that. I get 72 degrees. So there's a lot of stuff going on in this example, a lot of writing, but the essentials are what I just walked you through right there. Okay, let's do it again. This one's the same deal. You got an angle here. It's a 2-4-6 ratio. If you were to draw it quickly, it would have 2, let's say, something like this. It would be something like this, 6x, 4x. This is not a perfect example, but this is much smaller, you can see, 2x. Geometrically, you always want to try to as closely represent the real thing as possible. So if I sum these are all measures of degrees. So I need to add them together. 2x plus 4x plus 6x is going to add up to 180 degrees. How many x's do I have here? I have 12 of them. This is a little more difficult of a division problem. I'm going to divide by 12 on both sides. Draw my wall, and let's do a quick division. 180 divided by 12. 12 goes into 18 once. I'm left with 12, subtract 6, 0, 5, 60. Perfect, no remainder, so x equals 15. 15 degrees. So I have two x's here. So this angle is 30 degrees because 2 times 15 is 30. And now I have, if that's 30, 2x is 30. 4x is double that. This is 60 degrees. Okay. And 6x is 3 times that, so that's 90 degrees. You have a 30, 60, 90 triangle. So these are the angles on the inside, okay? These are angles inside. Just because I wrote them on the outside doesn't mean they're not on the inside. Those are interior angles. Inside, interior. Inside the triangle is interior angles. That leads us to what happens with this special case of a single exterior angle. Here's our triangle drawn here. And look at this one ray. They've taken this ray and they continued it going this side of this triangle, and it keeps going out past the triangle. And it creates a special angle right here. This angle called 1. Okay, well let's call this angles 1. We'll call this 2 and 3 and 4. There's an angle over here. What this theorem says is that this angle 1 is equal to these two added together. And we call these the remote interior angles. They're called remote because they're far away. Write that down. Far away angles. And they're also interior. That means they're inside. These two angles are inside. This is outside. So the outside angle, angle 1, is equal to the two farthest away inside angles. Angle 2 plus angle 3. And I should put measures in here. Okay. So then we have a little summary here. In addition to its 3 interior angles, a triangle can have an exterior angle formed by one side of the triangle and the extension of the adjacent side. Each exterior angle of the triangle has 2 remote interior angles that are not adjacent to the exterior angle. Okay, that's just saying that you can have this happen 3 different times. So this angle 6, it would be equal to 1 and 3. And angle 5 here, here's the remote interiors. Angle 5 would be equal to angle 1 plus angle 2. And angle 4, it'd be equal to these two guys right here. Angle 2 plus 3. Okay. And they have that right here in color, which is really nice. That's one beautiful thing about your book. It's got all this color. Also, you'll come across these stop and reflect. That's a good thing to do. You want to make sure you read these things. Measure angle 2 and 3 and 4. Where's 2 and 3 and 4? 2, 3, and 4. Okay. To verify that you can actually measure them. So that they're saying you can go ahead. You could actually take your protractor and you can measure that angle. Angle 4 looks to be about 110 degrees. So if I was to measure angle 3, which is 60, and angle 2, which is 40, 110. Yeah, that adds up. So you can use your tool if you have one. Let's move on. Example 3. Suppose you have measure of angle 4. Let's put it here. Let's just put it in there. 135. And now we'll identify the remote. Here's the exterior angle. So where are the remote interior angles? It's this angle too. Uh-oh. They don't have an angle for angle LKM. This is angle LKM. They don't put a number there, but they have a mark. What does that mark mean, I wonder? Well, I think I told you. It's 90 degrees. So we have a lot of good information here. We know that this angle, angle 4, the 135 degrees, it's going to equal angle 2 plus 90 degrees. I can use my mental math to answer this, which I will. Angle 2 has to be what plus 90 will get me there. Not 100. 100 plus 90, that's too big. How about 50? 50 and 90 is 140. That's too big. Okay, let's try 40. 40 and 90 is 135. So it's between 40 and 50. It's got to be 45 degrees. There's better mental ways to do that. So maybe you know a better strategy than I do, and that's super. Subtract 90. Algebraically, we do the inverse operation of it adding 90. We subtract 90 and we cross it off. And we draw a wall. We're left with measure angle 2 on the right. And we have 135 minus 90. If I want to borrow here, I'd borrow from that. 2, 15, 15. Wait, I don't need to borrow. I don't need to borrow there. It's 13. 5, 4, 13 minus 9 is 4. Got it. And we finally have our angle. One final problem here. Refer to the figure at the right. Again, we have angle 5 given as 147. Now we got to find angle 5. It's 147. Again, here's the remote interior. There's the exterior. Remote is far away. We don't have a measure here, but we have this mark, which means it's 90. So we just do it again. Measure angle 1 plus the 90 has to add up to 147. Using mental math, I know this has to be 57. Now we can do it algebraically. We subtract 90 from both sides. Draw a wall. This time I do need, 7. 14 minus 9, 5. Got it. So angle 1 is 57 degrees. Your homework is independent practice. It's pages 393 to 394, number 1 through 15 for periods 2 and 3, and number 1 through 12 for periods 4, 5, and 6. In addition, you have this other additional homework, which is vocabulary. Vocab. It's a fun vocab, and it will be due at the end of Unit 1, which is on your Google Classroom. It's been posted. It's the week of September. The week of September 23rd through the 27th. September 23 through 27. So you have about 2 weeks to do it from the date of this recording. Well, good luck. I hope you have... I will be posting solutions to the independent practice as we do them. So check back on the Google Classroom for attachments on PDFs. Okay, good luck.